Ladies and gentlemen, welcome to Famelab International Semi-Finals. Please welcome your host, Quentin Cooper.
Hello, indeed I am Quentin Cooper, tweeting as @QWERTY. Welcome to this second Famelab International, or if you prefer, International Famelab Tremi-Final. I know the voice is going to keep saying semi-final, but it is actually technically a Tremi-Final because there are 3 of them. And you are doubly welcome if you also were here for the first one at 10 a.m. Give us a yell if you were at the first one as well. Yeah. Ooh, quite a lot of you, okay. And now give us a yell, that lot, and anybody who's had any previous dealings with Famelab. Yeah. Technically that should have been louder, but it wasn't, but we'll work out why. And now a small squeal if you are completely new to this, and this is your first Famelab thing ever. Okay, that's good. That's it, that's the audience participation over. You can relax now, that's fine, okay. Okay, so all I need to tell you, congratulations, you have stumbled on the world's largest, most beautiful, most brilliantly hosted science communication competition. Dozens of countries involved all over the world, every continent apart from Antarctica. NASA have had their own version of it, CERN have had their own version of it, and this year 27 countries have had 27 national competitions and sent 27 people here to Cheltenham. And we thought it was a bit harsh to force all of you to watch all 27, brilliant as they are, so we've split them up into 3 Tremi-finals, of which this is the middle one. And from each of those Tremi-finals, our 3 judges, who you'll meet in a moment, will be sending through 3 people to tomorrow night's final. And you should also know that what you're also going to get is each person who comes on will give you 3 minutes of scintillating, fascinating science. Then there'll be 2 minutes of questions from our judges. So today is very much a kind of D-Day. It's decision day for those 27. And what's nice, of course, is it is also historically D-Day. June the 6th, 1944 was the date of the Normandy landings, Operation Overlord. It's also 25 years to the day since Mongolia first held direct presidential elections, but that's probably less relevant. So for this D-Day, simple task, even though everyone here has won through national heats and finals to become a national champion, we have to get the number down. So the judges will be reducing it down to 1/3. Loads more details I could go into, but it'll all make sense when you start seeing it. But all you need to know is you're going to see some fascinating, scintillating, stimulating slivers of science from all over the world, and it's free. What's not to like? Right, okay, so before we get to the first Famelabber, there are those 3 people you need to meet, our judges. So could you welcome them to the stage with some applause? First of all, biologist, bug botherer, broadcaster, including being one of the presenters of BBC World Service's Science in Action, and also Professor of Science Communication at the University of Gloucestershire, Adam Hart. As head of science at British Council, she was one of the key figures in helping Famelab spread across the world, but she's now Senior Director Europe for the National Geographic Society, Dr. Claire McNulty. And long after the devices featured in Channel 4's The Gadget Show have broken, long after the cosmic microwave background from BBC One's Bang Goes the Theory has faded, he is still on our screens hosting a whole range of top science, engineering and other programs, and only a couple of years ago he won Celebrity Mastermind with movie maverick Werner Herzog as his specialist subject. Applause please for the enigma of Dallas Campbell.
Did there.
See what I did there? Yeah. About, yeah, fine. Adam, yes. Picking 3 from 9 top communicators, national champions, is a pointless, impossible, difficult task. What on earth made you agree to do this?
I was free this afternoon, so I thought... No, I've done this before a few years now, and it's fantastic. You get to see all kinds of stuff, but the other really good thing for me is that you get to learn a whole load of new stuff. You know, every one of these people will be presenting stuff that I don't know that much about, and that's fantastic.
Yeah, because that's what science communication is about. Claire, you 3 judges have to be kind of like a hive mind working together. There are criteria, the official criteria of content and clarity and charisma. But what will you particularly be looking for to make the difference between someone who's come this far and someone who gets to go the extra 50 yards to the venue for the final tomorrow?
I think for me, there are always two things that always get me. One is passion, if they've got the passion for the topic and they really care about it. But the second thing that really works is storytelling. So if someone takes you and you're kind of with them on a journey throughout their presentation, that works really nicely.
Dallas?
And I've heard that there might be fisticuffs as well later, so I don't know about the hive mind.
That's not officially on the programme I knew about. I didn't know there was a boxing element.
There may be a punch-up.
We may have a punch-up later.
Right.
So.
It can get violent. I mean, I was doing a Famelab judging a few years ago, and we got into terrible trouble trying to decide who won. You know, it's when you have people.
How was it resolved?
Not with violence, I should say. Arm wrestling. We arm wrestled for it.
Okay.
Yeah. We didn't really. No.
Okay.
I can't remember how we flipped a coin. Or
You flipped a coin.
Yeah.
That's what it's all come down to. You come all this way and coins may be flipped. I also mentioned that you're on Mastermind with the great filmmaker Werner Herzog,
Yes.
especially. Now, I'm also very fond of Werner, The Enigma of Caspar Heuser.
Yes.
One of my favourite films.
Great
and it
film.
contains, now here's your trivia question.
Okay.
It contains my all-time favourite screen credit. So the German writer, artist, surrealist filmmaker Herbert Achtenbusch has a small role as.
Yeah,
And if you get this right, I will eat my shoe.
Well, yes, as of the film. I think he played the circus ringmaster.
He is in the credits
No.
as Bavarian chicken hypnotizer.
But that's what I meant. But he's also the guy who hypnotised the chicken.
I'm sorry, it's the exacting wording here.
Okay.
While you're here,
But
we
yes.
should also plug,
Yeah, yeah.
as well as all the other things, you're also of your book Ad Astra,
Yes.
which is about, I think, 40 years of really brilliant Vauxhall car campaigns.
Exactly right. Yes, I start with the Mark I and then go through.
No, perhaps you should give the real.
Yes, it's a book. Well, it's about the sort of history and philosophy and culture of spaceflight, really. And I start from the 2nd century AD through to the sort of Jacobean space program through to now.
Little known Jacobean.
Yeah, it's quite intense, the Jacobean space program. It involved a lot of geese flying to the moon. Anyway,
See,
yes.
we've barely
talking about
started
that.
and we've mentioned a geese and a chicken, you see. That's
Yeah.
what you don't get with
You'll
Famelab.
like it. It's quite Herzog. I nicked a few Herzog lines, which I've smuggled in.
I'm waiting. My free copy, we'll sort it out
Okay,
later.
I'll sort you out.
Okay, less ramble, more rumble. Remember, there are no winners or runners-up. What they are choosing are 3 equal people to go through to the grand final tomorrow. Still going to be tricky, so can we give our judges a preemptive flurry of applause, please? So that's up. And there is also an audience vote winner who will go through. I'll explain how you vote later for those who've just joined us. But the important thing to know is your winner goes through whether or not the judges agree. So if you're in accordance with the judges, 3 people will go through. If you have a slightly different take on things, 4 will go through. We've already got 4 through from the first one. Kind of hoping it doesn't happen again, but we'll see what happens now. Right, seconds out, seconds in, second semi-final. First up is Famelab, is our new champion from Bulgaria, Boris Yanashkov. Boris is a third-year chemistry student at Sofia University, which is great because he loves chemistry and reading and doing experiments in the laboratory, always hoping to spot something new to contribute to the development of science. He says his goal is to learn something new every single day. And today, maybe he's going to learn the formula to make it to the grand final of Famelab International. It is not easy going first, especially with a noisy event in the next venue. So an extra Bulgarian boost of applause, please, for Boris Yanashkov.
Hello, my name is Boris, and I live in Sofia, the capital of Bulgaria. And we have a problem with the air pollution. Because in Sofia, there are living about 2 million people, and we have about 1 million cars. And every day, the cars are traveling constantly. And most of the people travel alone, and that makes the problem even worse. And I, as a scientist, have a solution for this problem, may have a solution for this problem, and the solution lies in hydrogen and hydrogen-fueled cars. Because hydrogen-fueled cars are very clean, and by driving a hydrogen-fueled car, you produce only clear water on the spot. But there is a dirty secret to that cleanness of the cars. The dirty secret is that nowadays the hydrogen that's produced in the factories is produced by a process that is called steam gas reforming. That means that natural gas and steam are combined at high temperature to produce hydrogen and carbon dioxide. And for every kilogram of hydrogen, there is produced 5.5 kilograms of carbon dioxide, and that's a lot. Even I was born a 3.5 kilogram baby when I was small. But I think there is a solution for this problem. Today's technology is very advanced, and we have a solution which uses carbon neutral sources to produce that hydrogen, microorganisms that produce hydrogen. And for me, the solution may lie in my friend's work in the next door laboratory in the Sofia University, which are working on a special type of photocatalysts which use sunlight and water to produce hydrogen and oxygen. And how is this possible? The photocatalyst is made up of special material which absorbs sunlight and converts it into electrical energy. And that electrical energy splits the water molecule in half into fuel and clean, breathable oxygen. No pollution, no carbon dioxide involved in this process. And with this kind of technology, today in Sofia we have whole two cars that are fueled by hydrogen. But I think with the involvement of this kind of new technologies that produce clear hydrogen, in my lifespan, those two cars can be raised up to 2 million cars. Thank you for the attention.
Brilliant, Boris, thank you very much. Welcome to Cheltenham. I just want to ask, firstly, there's so much new car technology being talked about at the moment. Just really quickly, in 10, 15 seconds, how does a hydrogen car actually work?
Hydrogen cars work by hydrogen, which is pumped in the reservoir. And through that, it doesn't go into a regular engine. It goes into a special type of cell that is called fuel cell. And then the chemical energy that is stored by using the fuel, hydrogen, is converted to electrical energy that is powering electrical motors that are powering the wheels. And that's the kind of movement, that's the process that the movement is achieved through. And the only thing that is released when the hydrogen is burned in that kind of fuel cell is water.
So it's not burned, it's not burned.
It's not burnt like you light a candle and burns. It's different kind of chemical reaction, electrochemical reaction.
So can I just ask, are there any safety aspects that you need to think about when using hydrogen cars?
Yeah, there are a lot of things that you have to concern when you use that kind of technology, because hydrogen is a flammable gas. It is very light, and for me that's not really a problem, because in different kind of technology we use natural gas, and the natural gas is relatively the same flammability as hydrogen, and we use natural gas fairly a lot everyday use. And it's a little bit of a step to step from natural gas to hydrogen. It involves a little bit of danger, but it can be achieved and it can be applied in practice.
Okay, have to stop you gassing there. Our champion from Bulgaria, Boris Yanachkov. A couple of things to know. I don't know if you noticed, Boris was wearing, the pattern on his T-shirt was a little one of dogs. And Lucy, I think, Lucy Garr, the UK champion, the first one, had a little pattern of cats. So if they both get through to the final, we'll need to keep them apart. Also, very sweet. I love the way you said, "Can I just ask?" You're a judge. You can ask whatever you want. You don't need their permission as well.
They're very polite in the
I know, I know. But it's so sweet. Can I just ask? Yes, of course you can. Yeah.
Fighting afterwards.
Fighting afterwards.
Yeah.
Okay, right, that's our Bulgarian champion. So Sofia, so good. If you didn't quite get the idea before, you should do now. 3 minutes of thrilling from our Famelab national champions, then 2 minutes of grilling from our Famelab judges, and the whole thing comes round again. And in at number 2, the order I should say is entirely random. We have our winner from Germany, Veli Vural Uzlu. As may have guessed from the name, Veli is of Turkish extraction. As you probably can't guess from the name, he's a National Olympiad double medal winner in chemistry and maths. He got his BSc in molecular biology in Turkey. He then had an interesting international internships in Italy and the USA, and he then did his PhD on mouse developmental genetics at the European Molecular Biology Laboratory in Heidelberg, Germany. After that, he finally stopped moving, or at least moving so far. Veli's still in Heidelberg, but he's now at the university's plant physiology department doing his postdoc and using the extra time from not moving everywhere for things like entering and winning Famelab. So plant your hands together for our second Tremi finalist and our Famelab Germany 2018 champion, Veli Voral Oslu.
Oh, Cheltenham, I'm a bit anxious because I'm going to be under the spotlight in a very major scientific scandal. Or maybe a Nobel Prize, so I don't know yet, and this is up to you. So that's a bit of an odd situation, let me explain. So I'm a guy, I like cleaning, and cleaning is a very general habit. All animals clean themselves. For example, the cats lick themselves, the turtles, and even the worms, they clean themselves. So because if we don't clean ourselves, we live shorter because of bacterial infections. But my problem is, I can't stop cleaning. I love cleaning. And it's not only me. There are also some mice, for example, that are cleaning themselves so much that their skins are wounded. And the pups of these mice are also obsessive. So this means that actually this behavior must be genetic, and there must be something wrong with their brain. And when you look at the DNA of these obsessive mice, actually, one of the genes is missing. And this gene is unbelievably not in the neurons of the brain, but actually in the white blood cells in the brain. So this is weird because we always thought that the behaviors are controlled by our neurons, billions of neurons. But it looks like a white blood cell can control our cleaning behavior. Is that even possible? And when you transfer the blood from a healthy mouse to an obsessive one, actually you can cure the behavior. And this is big. It is very hard to change the behaviors. Albert Einstein said, it is harder to crack a prejudice than an atom, like with the German accent. So probably, so that's why this is a really big thing. That it's so easy to change a behavior, to cure a psychiatric problem with just transferring blood. Cheltenham, today what I want to tell you is that the underlying reason of my cleaning habit actually can be used for, in democratic societies, to create a healthier, psychologically healthier population. But in an authoritarian society, then it can cause, for example, mind-controlled masses. So that's why it is up to you, basically, to decide what should be done with this information. That's why I think science communication is very important for you to get prepared for future challenges. And that's why I'm here, beyond any competition, to tell you that you should get prepared for the future challenges. And that's why I'm telling you the scientific reason behind, or the mechanisms behind, so you can decide for your future with your own free will while you still have one. Thank you.
Right, so I'm quite interested in this kind of stuff, the manipulation of brains by things other than what you think. What sort of mechanism could there be for white blood cells to control behavior that way?
So this is, the white blood cells are the immune cells. So they are, for example, if there's a bacterial infection, so they move to the infection site, and they actually fight directly with the bacteria. But by evolution, a mechanism developed where some of the white blood cells, called microglia, actually they enter the brain, and then they just go around the brain to clean, for example, if there are dead neurons or there are bacteria. But these cells basically somehow manage to influence the neurons to dictate a cleaning behavior, so they don't have to work, basically, when there's a bacterial infection. So it's sort of a preventive medicine for the body.
Cool.
And are there other behaviors that have been shown to be influenced by
So this is a rather new development. So this is the first behavior that we know of, but this is for sure a major, a very important question, what else we can change with the blood.
And so you were sort of talking a little bit broader at the end. If humans had blood transfusions, are we going to see different kinds of behavioral changes?
This we don't know yet, but that's another interesting point, because we know that, for example, with the blood transfusions, it is possible to blood transfusions from younger individuals to older individuals make the older ones feel better, for example, from many different metabolic screens and so on. So that's why it is a very interesting question.
Okay, have to leave it there. Maybe you'll clean up. Maybe you'll get the brush off. Benny, bit of Russell. Thank you. Nicely done. So will it be a case of Vene Vidi Vici for Veli Voro Uslu? I'm throwing in Latin at no extra cost. It is too early to tell, but we'll get a better idea after we've seen the rest of the remaining magnificent 7 Famelabbers. And the first of those is our Spaniard in the works, Juan Margalef. Juan is currently doing his PhD at UC3M and CSIC. That's the Carlos III University and the Institute for the Structure of Matter in Madrid, if you don't speak Spanish acronym. He says his studies have enabled him to enjoy the universities and daily life of Brussels, Vienna, Rio, Erlangen and Barcelona, and now victory in Famelab, Spain, has brought him to Cheltenham. Juan is a big believer that answering apparently insignificant and random questions can lead to significant scientific advances. So he should be fine when it comes to dealing with the judges, but what about the next 3 minutes? It's no Spain, no gain for Juan Margalef.
One, 2, 3, and so on. In mathematics, we call these natural numbers. But I was wondering, are they really natural? I mean, there could be an alien race that counts in a different way, or that doesn't count at all. Or are numbers so natural that they are innate to an intelligent being? Oddly enough, we don't have to wait for aliens to visit us, because there exist some tribes in Australia or in the Amazon with numeric languages. That is, they have no words for numbers. When I learned this, I was amazed, and I spent days trying to understand how it would be to live without numbers. For instance, think about it. Would a mother know how many kids she has? No, she can't count, but of course she knows who they are. Or even the concept of time should be entirely different. They cannot talk about 3 years ago or in 2 days. I couldn't help thinking about how I would try to show them what numbers are. And this is what I came up with. I will ask them to imagine that this, a paperclip, is the only kind of object in the world. It can represent anything, a tree, a rock, a fish. Naturally, I can have another one, a fish and a fish. And that's how these tribes see it. But I would like to merge them somehow to create a larger group. Well, let's do this. Now, I have created a new object that didn't exist before, and that represents the new concept, fish, fish, two fish. Of course, I can repeat this process, and I would have the new concept, fish, 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 and so on. Well, this is exactly what we do in mathematics to construct the natural numbers, using what is called the Peano axioms, 5 rules that go like this. First, there exists an initial object that begins the construction, called number 1. Second, we can always attach a paperclip at the end of the chain to obtain the next number. Third, we cannot attach the first one to the last one, because we couldn't continue, and there's a lot of numbers left. Fourth, we cannot add a paperclip to the middle of the chain, because we want a queue with no bifurcation. And fifth, the tricky one, which is called the induction axiom. Roughly speaking, it tells us that every natural number is obtained through this attaching process. So we end up with a single infinite chain of paperclips. These are the Peano axioms, and they tell us that if we want to count in a sensible way, this is the only possibility. But I still wonder, are numbers really natural? Is it so strange that these tribes don't count? Or maybe what should be surprising is that we use numbers at all. In order to answer these questions, I'm afraid that we need more data. For instance, we could retrieve it asking some aliens how they count. So if you know any, please let me know. I'm counting on you.
That was really interesting, actually. I didn't know that there were tribes that didn't use numbers. And what about children, and children as they're learning numbers? How do you see them using this model?
Well, this is a model that I don't know if it's the most useful. It's the one that I like. But for instance, in children, it's nice because numbers is a very abstract concept that they don't really get. But for instance, they understand pretty well what is called bijection. Like if you ask to, can you put the table for the whole family? Maybe they don't know how many there are, but they know, okay, there is one plate for mom, one for dad, one for my sister, one for my brother. And this is a bijection. And this is something which is quite abstract, but seems to be like very innate to children. And this is pretty nice. And numbers are not. So maybe a good way is also talking about this kind of bijections. Understanding numbers, but okay, if I have a brother, a mother, and a sister, that's 3, and I can biject, which is called in mathematics, with number 3. Another way would be like that I like because they're giant paper clips and they're cool. I don't know if that's answered your question. Yeah.
You asked if there were any aliens around. We kind of do have aliens because there are non-human animals that we know have some sense of counting and numeracy.
Yeah.
How do you think that plays into your kind of ideas about
Well, it's pretty
numbers?
interesting. There are, for instance, it's well known that some parrots are able to do like simple maths. It is still a question of huge debate, I think, among the experts about if they are understanding what they're doing. And this is something I don't feel confident to say, but I will say that they do understand. Sometimes they say, okay, just ring the bell, 2 plus 3, you have to ring the bell 5 times and whatever. But some people would say, okay, they have just learned that every time that you say 2 and 3, they will ring the bell 5 without understanding what they're doing. But I don't know, I would like to think that they are understanding. So yeah, that I would say, yeah.
Okay, parrots can't just do simple maths, they can do polynomial equations. Oh, never mind. Okay, will he be numbered among our winners? Please thank Juan Margalef. So he may reappear in tomorrow's funnel. I should also say Juan is here by royal approval because, I don't know if you know this, but Spain's Queen Letizia is a big fan of Famelab. She was fan even before she was en-monarched. I think that is the correct term. And she's been going to the final for years, and she went along to this year's final along with the king, King Felipe. And did she hand over the prizes? She certainly usually takes part in things. Yes, so he is here by official royal approval, but that should not sway our judges in any way at all. Next, and at a travel distance of just over 10,000 kilometres, which makes them just the furthest flung of the Famelab champions in this semi-final, we have our Thailand winner, Apivich Hemachand. A physics undergraduate, Apivich is aware that a lot of people find his field difficult and unfathomable. But he believes that physics shouldn't be seen as a mystery, rather as a subject that solves mysteries. And he's got interested in sharing his knowledge to help people understand the truths and insights that science can bring, particularly physics. Things like, well, you're going to hear about in the next 3 minutes. So, Bangkok, your hands together for our Thai guy, Apivich Hemachand.
We invented computers because we realized we're quite rubbish at solving a lot of problems. But the problem that we have now is that the computers that we have built turns out to be not that good at solving a lot of the problems that we have found. Problems like simulating the weather, for example, or searching through really large databases. And if our computers won't do the job, we'll need something else that will. And this is why we invented something called quantum computers. Now, classical computers does calculations in terms of ones and zeros, or what we call bits. But quantum computers are different, because rather than using these bits to calculate, they use something else called quantum bits, or qubits as we call them. And rather than these qubits existing as ones and zeros, they instead only exist as a probability between these different states. You can think of it a bit like a coin, where all you know at any one time is just the probability of it landing on one side or on the other. But only when you actually take your coin and you flip your coin will it actually become one of those states. And if you want to do any calculations with these qubits, you need to adjust the probabilities so that the more favorable outcome is more likely to happen. But how is dealing with the probabilities of qubits going to help solve problems any more efficiently? Well, let's look at a particular problem that we might have. Let's say problems like, let's say we have a deck of cards, and we want to find where a smiley face card is, but it's somewhere in your deck. How are you going to do that using any quicker? Well, classically, what you have to do is you have to go through every single card one by one until you find the correct answer, but that takes way too long. we can use quantum computers and we can exploit probability and quantum mechanics to do the problem a lot faster. What we want, let's say we have a deck of cards initially, what we technically want is we want to make sure that if we were to pick a card at random, we're more likely to get the correct card that we want, the smiley face card. If I were to pick now, then it will be equally likely to get any of the cards, right? So what I can do is I can run this problem through some quantum algorithm and maybe run it again just to be really sure, so that when you actually pick one of the cards out of your deck, you're actually really likely to get the correct card that you want. And you know that this is going to be a lot quicker as well, because rather than having to go through all of the cases one by one, you're actually dealing with all of the problems that you have all at once. And that's what makes quantum computers a lot quicker, because rather than having to deal with more exact things, you can just deal with the probabilities and do everything all at once. And while quantum computers are still pretty much in their infant years, it still remains a really great prospect for the future of science, and only time will tell us where it takes us. Thank you.
Thank you very much. Welcome to Cheltenham. Thank you for flying 10,000 kilometres.
Yes.
Do we have any quantum computers yet? Where are they? Why don't we have them? How do you build one?
Oh, wow, that's a lot of questions. Let's see if I can go one by one. With the current technology, we currently have built some machines which might somewhat resemble something that quantum computers can do. We have, although the only problem is that most of the machines that we have built are mostly there to do very specific problems. So there's a machine which claims that they can do problems in optimization and so on. But we're still quite far away, and we're not sure how long until we actually have a quantum computer in the sense that we could program it the way that we can do with current computers. And what was the other question?
Well, how does one build a quantum computer?
Well, okay, so the most fundamental units of quantum computers is something called quantum bits, right? And there's still many methods that we have been looking at to build these quantum bits. What we need some systems which has got two states. So there's many such systems in quantum mechanics. Maybe we have an atom which can exist in two energy levels, or we have an atom which has got two spins. When you apply a magnetic field, it might be pointing up or down. And those systems have got two states, which are going to be the bits that we can use. Although these different methods of building quantum bits are still being looked into, because many of them has got many advantages and disadvantages and might be more suited for some applications and maybe not for another.
Yeah, my question was actually going to be quite similar in that I can get my head around a microchip and what it looks like, but I can't quite get my head around what a quantum computer would look like. But I think you've sort of answered that in that no one's quite there yet. My next question was, how much quicker is it likely to be?
Well, currently, there's only only a very specific set of problems that we have mathematically proven out and said that it will actually be faster. We found that there might even be problems out there which quantum computers turns out to be a lot slower, because we have to run through this algorithm of changing probability more and more. But for problems such as searching through cards, which more realistically would be searching through really large databases, for example, we can prove that it will be a lot quicker, because in more mathematical terms, the complexity of searching through cards currently we're using computers would be proportional to the size of the list that we're trying to search, but for quantum computers, it will be proportional to the square root of the size of the database which we need to search, which of course would be a smaller number, and that will be one of the problems that will be a lot quicker to solve. Yeah.
And as I understand, they can't get the computers to clear up the cards afterwards.
Yeah, I'll probably just do that myself, I guess.
Quantum mechanics and quantum magic from our Thailand winner, Hemachan. I'm just going to take a few bonus cards. And if you're wondering, the DRA at the is silent. It's not that I can't say Hemachandra, it is Hemachan, which took me a while to realise. Now, we are at the exact halfway point. We're on the 5th of our 9 finalists in this semi-final and the 14th of all 27 today. And right in the honeycomb middle, we've our Malteser, Anthony Gallia. A geosciences lecturer at the University of Malta. Anthony's current area of research is currents. Ocean ones, and how to improve marine safety by predicting them more accurately. He says he's very big on turning lectures into mini shows by using exciting props and it clearly works. As well as winning Famelab Malta, he also won the People's Choice Award there as well, and he also won, a couple of weeks ago, Malta's National Public Speaking Competition, and in a fortnight he's off to represent Malta at a European showdown in Latvia. That, though, is the near future, and it's only against the rest of Europe. His current concern is the next 3 minutes and taking on the whole world for a place in the final of Famelab tomorrow. He's here to launch an attack, a shower curtain attack. Please welcome Anthony Galea.
How often does this happen to you? You're in the shower curtain closed, water from the shower head, and then the shower curtain creeps in and touches your leg. Ew. I'm Anthony, and I will explain to you why the shower curtain seems to attack you, and how the same principle has changed the way we travel. So, let's start with a simple experiment. If I blow air between these two papers, will they move apart? Will they move closer together? Or will they remain where they are? Okay, let's have a show of hands. Who thinks that when I blow air between the two papers, they will move apart? All right. Who thinks that they will move closer together? And who thinks that they will remain where they are? All right, let's see who's right. So, I will blow some air between the two papers, and they moved closer together. Again. This is known as the Bernoulli principle. So what happened? When I blow air between the two papers, air on the inside has high velocity. Air on the outside has low velocity. The Bernoulli principle states that the velocity and the pressure are in some sense opposite. So in this case, we have low pressure on the inside and high pressure on the outside, which will squeeze the two papers together. Now, let's scale it up a bit. When we go to the train station, on the platform, there is a yellow line, which we should stay behind. But why? Because if I step on the yellow line and the train passes by, the train drags some air. So the air in front of me has high velocity. The air behind me has low velocity. By the Bernoulli principle, we get low pressure in front of me and high pressure behind me, which will push me towards the moving train. But what is the main application of the Bernoulli principle? Aeroplanes. Because given the shape of a wing of an aeroplane, air moves faster on top of the wing and slower below the wing. So by the Bernoulli principle, we get low pressure on top of the wing and high pressure below the wing, which will push the wing up, creating lift. Now, let's go back to my shower. Shower curtain closed, water from the shower head. This water is moving the air inside the shower. So we have high velocity on the inside and low velocity on the outside. By the Bernoulli principle, we get low pressure on the inside and high pressure on the outside, which will push the cold shower curtain towards my leg. But when the Bernoulli principle makes the shower curtain creep up your leg, cut it some slack, for it is the same principle that has revolutionized the way we travel. Thank you.
That was great, thank you.
Thank you.
So maybe slightly off-piste a bit, but we've been experiencing some strange weather recently.
All right.
And you know, different areas of low pressure, high pressure. How can you explain some of those
in the atmosphere?
In the atmosphere.
So basically, it depends if it is a local change of pressure or difference in pressure or a global change of pressure. Are we talking about global or local?
Local.
So local, it really depends on the structure of the area. So if we're talking about the atmosphere, for example, it depends on if there are mountains, for example, or if there's a river or seawater which cools down the air. Basically, it really depends on the area. And it depends if we're looking at the small time scale, so what is happening now and what will happen tomorrow, or if we're looking at the time scale of what will happen in 100 years.
I have a question, which is, I've often found talking to aeronautical engineers, and when you talk about how does an aeroplane fly, you get 10 different answers, and there's always a bit of a debate between Bernoulli and Newton.
All right.
Now, when an aeroplane takes off, which force is predominant? Is it Newton or is it Bernoulli?
Well, technically, it is still accelerating, so there's the Bernoulli principle there, high pressure below and low pressure at the top part of the aeroplane. And of course, there is also the push when it is taking off, and a lot of vortices around, which are crucial. So it's more the Bernoulli, yes.
Okay, very quick one then. How does a plane fly upside down?
How does a plane
Fly upside down.
It is the same principle with the aeroplane I just threw. So basically, at slow speeds, it can do that as well. So in fact, aeroplanes by the Bernoulli principle were invented after the first aeroplane. The Wright's brother aeroplane was not by the Bernoulli principle, for example. But when you increase the speed, then you need to use the Bernoulli principle.
Okay, a torrent of principled applause, please, for Anthony Gallia. I did find a great anagram of his name, but I could only use it after the 9 o'clock watershed. You're not worried, Dallas, when you hear that you talk to aeronautical engineers and they give you 10 different answers? Doesn't that make you think, maybe I'm not going to fly until you can agree on...
Yeah, no one's quite sure.
Yeah, I feel kind of slightly worried by the fact that even the aeronautical engineers, okay. Right, well, right now, Anthony may or may not be in our judges' top 3, but they've got time to alter their Malta views as we come to the final 4 Famelabbers. Already had our Thai guy. Now we have our gal from Portugal, Barbara Pinho. Famelab regulars, let's have a yell if you are one. Famelab regulars! Come on! I just thought a little bit of audience participation there. Famelab regulars will know there is many a Famelabber who comes here and talks about how they grew up and they always wanted to be a scientist, that practically from the cradle they were carrying out experiments and dreaming of having their own white coat. Not so Barbara. When she was a kid, she says she had her heart set on being a writer. It was only when she was older she realized what she really wanted to be was a horse trainer. Later still, before she finally alighted on her true vocation, journalism. So, as she says, funny how I ended up in biomedicine. But Barbara still feels that by adding in science communication, she can get to do all the other things she wanted, provided, as she says, she can find somewhere to put the horses. So you may be part writer, part horse trainer, part journalist, part biomedic, but for the next 3 minutes, she's 100% Famelab Portugal champion, Barbara Pinho.
Hello. We live in a constructed world in which everything has building blocks. Houses have bricks, humans have organs, and computers have IT parts. And usually, we tend to examine these building blocks in order to understand our planet a little better. And we are no excuse. We are made of atoms, yes, but these atoms are perfectly organized in molecules. And my favorite kind of molecules are proteins. You all have heard this word before, right? We all know what proteins are. Really? What are proteins, after all? Well, proteins are biomolecules. A biomolecule is a chemical compound present in living organisms and essential to some chemical processes. Now, proteins are the most abundant biomolecule in the entire planet. They are everywhere. Want to see? Picture a glass of milk. It has proteins. Hold your hair, feel it. It's also made of proteins. Think of a spider web. You guessed it right, made of proteins. They truly are all around us, and by understanding them, we may understand our planet a little better. Unsurprisingly, proteins also have building blocks. Proteins' building blocks are amino acids. Amino acids are smaller chemical compounds, also made of atoms, and they connect to each other to build a protein. To better understand this, imagine you there in the audience, you are an amino acid, and you have people by your side. So if you could all give your hands to each other, do it if you're friends, if you're not, let it be. If you all could give your hands to each other, you would be making a peptide bond. A peptide bond is the link between one amino acid and the other amino acid. So if the entire audience could give hands to each other, you guys would be making a protein of around, what, 60 amino acids. And this is fascinating because your structure would always give your protein a function, and you would have to work together in order to have a function. Now, even though this is extraordinary, My favorite part when it comes to the proteins world is the fact that my proteins have the same amino acids as your proteins and as the jury's proteins, even though they're just rearranged in a different way. Socially, we speak of equality as a civil right. However, it seems like nature has been doing it for such a long time. We're all so very different. However, we all have the same stuff, the same building blocks. Thank you.
Thanks.
Hey.
That was great. So when you're thinking about amino acids,
Yeah.
is it just the sequence of amino acids that's important, just one after the other, or is there something else that's important when it comes to proteins?
Well, when it comes to proteins, we have lots of interaction with the environment. If you put proteins in a pH, which is, for example, the level of acidity of a solution, well, proteins will react in a different way. It really depends on that. So amino acids, their order is important, of course, but the environment is also, it also plays a key role when it comes to understand the function of a protein. So it's also very important to see other factors.
Proteins are really cool and they do all sorts of amazing things, but to make them in cells requires a huge amount of machinery and catalysis and things.
Yes.
How can we try and make them outside of cells for our own use?
Well, we use building blocks, and it's fascinating because we've been using that a lot. We use amino acids, which are just like bricks, as I told you before, and we can put them together, of course, in labs. We can do it with amino acids, and now we can study proteins so intrinsically that we can understand, okay, this protein has A, B, and C. So I'll use amino acid A, B, and C, and voila, you get a protein.
Will we be able to see life on other planets? Will they have the same building blocks? If we explored exoplanets beyond
Well,
the Earth?
I have no clue. I don't know, maybe. Maybe they have if they have the same chemical basis as we may see it, but it's really an open question. Who knows they're made of proteins? Who knows they're made of something else we don't understand? It's fascinating to dream about it, but we don't have an answer for that.
We don't even know how they count. I mean, let alone what they're made of. So that's just going too much. Can we thank for our peptide pep talk, Barbara Pino. Anti-penultimately, last but two, we have our French champion, not a French champignon, that's a mushroom, that's something completely different. Assia Azria, a graduate of the Paul Sabatier University in Toulouse. Paul Sabatier being a Nobel Prize winner for which subject? Chemistry. Very good. In what year? Go for the
1909.
Oh, close, close.
1900.
No, he's going to take it. No, further away. 1912. But that was pretty good. And four, you'll get a real bonus if you say for what for?
Producing oxygen from water.
Well, well, hydrogenation of organic species in the presence of metals. Yeah, close enough. Bonus point for Dallas, please. Yeah, thank you.
Something like that.
Assia is now at the Institute of Pharmacology and Structural Biology, still in Toulouse, where she's looking at the relationship between immunology, cancer, and blood vessels. She says she's passionate about cellular biology, but what she likes even more is sharing that passion with the public, which in this case means you. From Toulouse, but here to win, our Famelab France champion, Assia Azria.
Hello, everybody. My presentation has 3 keywords. The first is me, okay? The second is Princess Kate Middleton. It works. Huh? And the first one is vomit. I'm sorry, Kate. It's not what you think, actually. I've never vomited on Kate or made Kate vomit. No. Let me clarify, okay? Princess Kate and I are among those 1% of women who during pregnancy have a disease called hyperemesis gravidarum. It sounds like a bizarre word, but actually it's just vomit. Vomit. No, you know, okay, sorry. Actually, it's just vomit. It sounds like a bizarre word, but it's just vomit. Sorry, I forgot my... But it's just vomit. I call it the VATDZ for vomit all the time. But this has a lot of consequences. You may suffer from dehydration, nutrient deficiencies, hospitalization. But the most frustrating for me is to not understand why me. I have consulted several doctors and explained to me that there are several hypotheses. Deficiency in vitamin B3, too much pregnancy hormone. And once a doctor explained to me that it's a way for my body to reject the pregnancy through the digestive tract. I had nightmares about it. But I'm not here to spoil the atmosphere. I'm here to tell Kate good news. About 3 months ago, scientists, researchers have pointed out the guilty. And the guilty party is GDF. GDF is a small protein which is produced abundantly in a pregnant woman with the disease. Indeed, what the researchers are doing is comparing the DNA from pregnant women with and without the disease. They have shown that in the case of the pathology, particular gene is somehow hyperactive and give rise to a lot of GDF15 protein. Actually, we all have little of GDF15 protein in our body. It is important to regulate appetite and weight gain. But when it is too much product, it will bind to its receptor in a surface of neuron in our area of our brain called the vomiting center. We can finally think about a therapeutic solution, which consists on molecule which is capable to block the GDF15 protein receptor and prevent us from making us vomit. You know, all the women will dream of blocking the vomiting center, but it's time to stop.
You've got a question?
I have a question. Vomiting is obviously extremely unpleasant, but it can also be very useful, particularly if you've ingested something you shouldn't. Is there a problem with blocking the vomiting center long term?
Yes. Actually, it's a problem for you to block the vomiting center. That's why it's difficult. Actually, we do not want to block completely the vomiting center, but the solution will be to reduce the amounts of the GDF15 protein. So we have to be careful. Actually, it's like another disease, cancer, for example, which induces anorexia, for example, cachexia. There is a lot of GDF15 protein and induce vomiting. So we have just to find the good balance between blocking completely and
and vomiting. I just love the phrase "blocking the vomiting center." I think
I just enjoyed you repeating vomit over and over again. Can I just check the Kate Middleton thing? I was a bit lost on that. She vomits a lot. Is this what happens?
It was.
Or is it a pregnancy thing? I see.
Yes, during pregnancy she vomited a lot. She was a lot hospitalized, hospitalized a lot, and it can have many consequences in a baby. It's very important actually to find solution for those just 1% of women. But it's render pregnancy very difficult and a handicap. I don't know, it's in English word, but for women. So you have to find a solution for her.
And I think I'm right in thinking that thalidomide was originally supposed to be a solution for this. Is that right? So how were they expecting that to work in blocking the vomiting?
How we can expecting that it could be a solution for the disease? How I explain? I don't know if it's the same question, but I will say.
Do you know the drug thalidomide that was used back in the 70s? I think 70s.
Yeah,
60s. That was originally used for morning sickness, but of course it had really grave problems in the babies that were born. I was wondering if you knew what mechanism they were hoping to address with that drug.
Actually, it's just we don't know really. This molecule do not exist yet. But what we know that we have just to reduce these amounts of GDF15 protein to not activate this vomiting center, inducing vomiting. It's just fundamental research now, but it gives a good hope for the future and for a new therapeutic solution for the disease. Thank you.
Okay, you never know each year what kind of subjects and individuals Famelab will throw up, but in this case, we congratulate our Famelab 2018 victor, Asya Azria. I now feel in a kind of Pavlovian way, I'm conditioned that the word vomit will make me think of Kate Middleton until the end of time as well. And so, should we just say just one more time? Vomit! Okay, we've got it out of our system now as well. Okay, last but one, and also furthest travelled but one, is our boy from Brazil. Guilherme de Fonte Teles. Guilherme says he is a typical Brazilian in that he spends most of his time enjoying cold beers, tasty barbecues, watching football and sambering. He really said that. It is not from the bumper book of Brazilian cliches. When not doing any of the above, Guilherme says from time to time, he also tries to understand how physical exercise can alter the expression of our genes through epigenetics, which is what he's studying for his master's degree. Perhaps Guilherme could go on to study how physical and mental exercise can alter gene expression when taking part in Famelab. Or maybe not. Anyway, for the next 3 minutes, he's not spending his time on football, samba, Barbie, beers, or even his master's degree side project. We're getting pure, undiluted Brazilian brilliance from Guilherme de Fonte Teles.
Today, I bring a special and scientific gift for each one of you here. Yeah, I bring the possibility of receiving health even before you were born. Yeah, let me tell you this story. A story that actually begins with the first gift of your life that you received from your parents, you know? Your DNA. Yeah, your DNA is something like this book here, where we find all of your characteristics written in your genes on the page of your book. And yes, among these genes, these gifts, you received both. Good ones that make you healthier, and at the same time, the bad ones related to some disease. But now you must be wondering, okay, if everyone received both good and bad genes, why are some people so healthy while others aren't and develop diseases? That's actually a question of choosing which page to read. So let's go back to our book here. When we want to read a book, we have to open it first, right? And we can choose which page we're going to read. And the same happens with your DNA. Your DNA is closed, packed inside your cells, forming a tiny structure called chromatin. But sometimes your chromatin is opened, and your genes can be read, or in scientific terms, expressed. Your cells control this open and closing process by many amazing mechanisms called epigenetics mechanisms. Epigenetics does the same thing that you do while you're reading a book when you mark the best parts of the story to go straight there when you want to, you know? Epigenetics marks your chromatin at many places called histones, controlling which genes and how much of them will be expressed without changing your DNA sequence. And the most important thing is that where these epigenetic marks will be placed is up to you. It depends on your lifestyle. Yeah, for example, if you practice exercises daily, your epigenetics will mark and allow the expression of the good genes and silence the bad ones, protecting you from diabetes or even cancer. But what's incredible is that these epigenetics marks can be passed on to your children. I mean, your current lifestyle can actually affect your next generations. So yes, you can give health to your children even before they were born through epigenetics. So think about that. Which gifts, epigenetic gifts, do you want to give to your next generations? Which ones? Because after all, now epigenetics can let me truly tell you that the future is indeed in your hands, or better saying, the future is in your epigenetics. Thank you very much. Take care of my DNA. It's important. It's me there. Yeah. Thank you.
So perhaps I can ask then, you mentioned a number of different conditions there that may be affected by epigenetics. Are there some where there's more evidence that the epigenetics and what your parents do has a bigger impact on your life chances?
About diseases?
About, you said cancer, I think,
cancer, diabetes. It's diabetes and cancer. They are the main topics of epigenetics now about diseases. And now we know that there are some genes that are related to these diseases. And when you exercise, you really can change these patterns in your gametes. So you can pass them on. So in my opinion, I've chosen these two ones exactly because of that. Yeah.
And is it equal from the mother and the father?
It depends. It depends. But So far, we believe that yes, but I cannot just tell you that yes, it's equal, but it's something that we cannot trust about science. Okay.
How much of epigenetics do we know? Is it still a lot of mystery in it? I'm very confused when I read about it. I read so much stuff about epigenetics, and I still don't quite understand how it works.
I'm sorry.
No. Yeah. I'm just wondering where you take on it as a sort of field of study. Where are we? And do we have a lot more to learn?
Yeah, there are a lot of. We don't know all about genes, and we are going to epigenetics. It's around the genes. So, if we just think about exercise, that's my field. That's a multisystemic stress. That's really complex by itself. When you put this together with this other complex word, that's epigenetics, it's a more complex word. But we can now, with some technologies, understand how and where these epigenetic marks can be changed. And that's the most interesting part now. Okay?
Thank you. Okay, Rio de Genetics from Guilherme de Fonte, tell us. Even his name feels talented, or at least the De Fonte Tellus is an anagram of feels talented. Okay, 8 down, 1 to go, and it's possible, but statistically unlikely we've saved the best to last. The order, I should say, is completely random, except for making allowances for those who are marking Ramadan, so it's more of a kind of Ramadandum order. And our final second Tremi-final Famelabber is our first ever winner from Bangladesh. New countries join the competition every year, and that winner is Alvi Islam. Now, a slightly unfortunate anagram of Alvi Islam is email slave, and his own description isn't much better. I am a short, fat guy, this is him now, I am a short, fat guy who started his academic life with the dream of becoming a doctor, but somehow ended up in studying EEE, Electronics and Electrical Engineering, which may explain the email slave part. Now that he's gone down the EEE route, Alvi, or Alv EEE, as he's probably not known, says he's always exploring, finding new things that amaze him, and having fun turning strangers into friends. He did that in winning Famelab Bangladesh, and he's going to do it again now in this Tremi final and maybe beyond. A double Dhaka welcome, please, to the first ever Famelab Bangladesh winner, Alvi Islam.
Ladies and gentlemen, hold on to your seats and pay attention. Today I will change your brain with my music and my words. Today I will actually change your brain because you are going to learn something new from me. And when we learn something new, our brain changes. Just like how I changed my brain when I started learning to play ukulele. This property of the brain of allowing itself to change is called neuroplasticity. Neuro stands for neurons, which are our nerve cells, and plasticity means the ability to adapt or to change. Neuroplasticity takes place in 3 basic ways to support our learning. And the first way is a chemical change. When we start learning something new, our brain increases the chemicals between the neurons, which are transferred from one neuron to another neuron to pass the informations. So by making this chemical change, our brain creates short-term memory. So when I took the ukulele in my hand at the day 1, I learned a lot of things. But on the second day, I forgot almost everything. Because in just one day, my brain only made the chemical change, and it only created the short-term memory. But it actually took 5 months for me to learn to play ukulele properly, and I had to practice a lot. When I practiced a lot, my brain made a physical change. And this is the second way how neuroplasticity takes place. In this case, our neurons grow longer, and they connect more neurons to themselves, and they create a whole new neural network. So this is actually a physical change which is happening inside our brain when we are practicing a lot in the learning process. And the third way is a functional change. When we learn something for a long time, it has been seen that activities in some part of our brain increase, and the activities in other parts of our brain decrease. So this is a functional change. So neuroplasticity takes place in 3 ways: chemical, physical, and functional. So now, as all of you have learned something new, some of your brains have already started changing chemical-wise, and some of your brains have already started making the short-term memories. But if you want to make them last longer, you have to go through this information on a regular basis, and you have to practice a lot, because your brain needs to make the physical change, because that's how we learn. And learning is all about neuroplasticity. Okay.
So I'm oh, go on, Lee.
Well, I was just going to say this has given me a really good reason to get my son to do some revision quite a few months before the exam, not just the night before. So thanks for that. That's something I've learned and I'm going to use.
You know what, Pam? After discovering this whole idea of neuroplasticity, so it's really connected more with the children, because some children can learn faster, but some children cannot, but with the same effort, because some neuroplasticity varies from children to children.
Well, that was actually going to be my question. If there are periods throughout our lives when the brain has more neuroplasticity, and does that decrease?
Yeah. So when we are born, the rate is higher, but as we start aging, the rate goes slower, but it goes on.
It's quite a well-known fact that London taxi drivers have a different brain.
Right,
I mean, as anyone that's been in a
hippocampus,
taxi will attest. Their hippocampus is a different size, and you can physically see that. Are there other well? If you get them in a machine or chopped up their head. But are there any evidence of... yeah, big one, yeah. Is there any evidence of any physical changes in other parts of the brain?
So far what I have learned and seen, that mostly the London drivers that you just said, their hippocampus is bigger because of it's connected with the memory, and they are like, they have to go to the maps, so they know the maps. So far, I know about hippocampus.
I'm very young.
Okay.
Why can't I remember anything anymore? What's happened? I can't remember anyone's name. I can't remember where I put my keys.
So, sir,
it's driving me crazy.
Even I am way younger than you, but I still can't remember anything. Sir, so it's connected with memory. It's not only connected with neuroplasticity. So when it comes to memory, considering the fact that you are totally fine, which means you do not have any ancestors who have problems with memory, if we consider that, I think that's because you do not put like extra effort or the amount of efforts that you really should, because it's really the connections in your brain. You make it, you go through it, you remember it.
So it's not an age thing, it's just I'm lazy.
Well, you're young, so age shouldn't matter.
Age before beauty.
Okay, and if you're lucky, he'll forget which one you were anyway, so you won't count against you. Okay, brain expanding. Oh, sorry, that's your ukulele. Brain changing stuff from Alvi Islam. And for those who were at the first semi-final, note ukulele, now the official instrument of science. Right, that is bang all the fabulousness, the Famelabulousness from the stage. It is now time for you and our judges to get to work. Judges, this is your brief window for winnowing, so we need 3 from 9. And you also have about 3 minutes or so to do it in for these big life-changing decisions. You'll be escorted off this way. Can we please send them off, because they've done a brilliant job of asking questions. Send them off with some applause. And the wrath of God be upon you if you can't do it in the sufficient time. Now, audience, this is your bit. Remember, your vote winner also gets a place in the final, regardless of whether who you choose tallies with their choices. What we need to do, we've rather bravely or foolishly put our trust in technology, and we want you to get out your smartphone or other internet-enabled device. If for whatever reason you do not have one with you, you have been technologically disenfranchised. Sorry about that. You can kind of, move along to somebody who has got one and have a little chat with them, but kind of keep it friendly. We don't want any lawsuits, okay? Right now, to heighten the drama as the judges reach the crescendo of decision-making, we're going to have all 9 Famelabbers back on stage. So can you welcome them back on stage, please? From the area of Bulgaria, Boris Yanashkov. German champion, Veli Voroluslu. Spaniard in the works, Juan Margalef. Thai guy, Apivic Hemachan. Malta Victor, Anthony Gallia. Famelab Portugal champion, Barbara Pinho. Formidable French Famelabber, Assia Asria. Brazilian Guilherme de Fonteles, and Bangladesh winner Alvi Islam. And now, can we bring back the cerebral Cerberus that is our three-headed judging team, Claire McNulty, Adam Hart, and Dallas Campbell. Brilliant, all right, and we have the audience vote winners. I love technology when it works. I hate it when it doesn't. All right, thank you, judges. Thank you, judges, for your great questions. Thank you also for being brief and actually understanding what 3 minutes actually is. All that stuff about quantum and numbers clearly paid off. You've got more neuroplasticity than you realised. I know you only had a few fractions of seconds to decide. You can't still be deciding now, can you?
No, I'm just writing down where people are from.
Yeah. Number 37,
Okay.
the cuttings.
Here we go, yes.
Yes.
Yeah.
So, just tell us, I mean, the traditional thing, but, you know, it can't have been easy.
It's never easy, and I'm always amazed. You guys have come from all over, all four corners of the flat Earth, as it's now called. As I was reading about it the other day, all four corners of the globe. And I just want to say, first of all, thank you so much for making the effort. I love Famelab. I've been doing Famelab and been involved with it for a number of years, and I always have a great time. I'm one of the Famelab trainers, and I kind of go out and work, not with any of you guys, but I know how...
got to the final.
Yeah, exactly. All of you, yes. I know how hard you work. I know how brilliant you all are in your disciplines. And I know, hopefully you've had a good time. Hopefully you've enjoyed the process of this. And it's been fun. And you'll have a nice time in Cheltenham. And Quentin's been nice to you.
Reasonably nice. And we stressed the reason why there isn't one of the ones Dallas trained in this semi-final is not because, of course, he was rubbish. It's because we've obviously kept him away from somebody who he might have a personal interest in.
Exactly.
We try and do that sort of thing as well.
But I understand the process that you've been through, and it's thank you for being here.
Any other comments from our other two judges?
Just, it's always nice to learn something new, and I feel like I have this afternoon, so thank you.
Yeah,
and Claire, at the very least, you can get a subscription to National Geographic to Dallas to explain about the four corners theory. You might need a bit of updating. So, okay, well, look, we cannot do the names because unless we were quantum computing, we cannot do the names all at the same time. We have to do them sequentially, but these are all equal, and give us the order in whichever way you wish.
Okay, so this is the three in no particular order. First of all, Barbara Pino.
Step forward. That is you. That's great. I love the way Barbara said, "That's me." It's good. That's good.
Oh no, it was the other Barbara Pino. Sorry, it was someone else. Brilliant. Next up is Alvi Islam.
Woo. Oh.
And finally, from Germany, Willi. Willi Gula Usri.
Right. And that is it. Unless, of course, there is a different name in this envelope. This is your vote, audience. So now the maths is really stacked against you. It's only one of six, or possibly none of six going through. I've no idea what this is, but this, if it's a different name, we'll join them. And if it's the same name, you're already there. And once again, it's another name. That means we now have 8 people in the final already, with 1 heat to go. And the 8th, the audience vote winner, Juan Margalef. That is it. Thank you. Can we please thank for their brilliant work our judges, Dallas Campbell, Adam Hart, and Claire McNulty. Round of applause for them. Come on. To all 9 semi-finalists, stop the high fives. You've got plenty of time to say. All 9 semi-finalists, please deserve a round of applause. Thank you.